Welcome to the session on the normal distribution, finding the mean mu and the standard deviation sigma. The objectives for this session are to find unknown means as well as standard deviations for a normal distribution. We're going to begin by recapping some of the notation and some of the characteristics of the normal distribution. Suppose x is a normal random variable which is distributed normally with mean mu and variance sigma squared. Then if we let z equal x minus mu divided by sigma, then we have that z is distributed normally with mean 0 and variance 1. Recall from the previous session that phi of a is equal to the probability that z is less than a. In other words, the shaded region shown here. We may need to find an unknown mean or standard deviation for a normally distributed variable. Let's take a look at an example. The random variable x is distributed normally with mean mu and variance 4 squared. Given that the probability of x greater than 30 equals 0.3, find the value of mu. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. Since the probability that x is greater than 30 equals 0.3, we therefore have that the probability that x minus mu divided by 4 is greater than 30 minus mu divided by 4 equals 0.3. Notice that we've subtracted mu from both sides and divided by the standard deviation on both sides. And so we have that the probability of z is greater than 30 minus mu divided by 4 equals 0.3. This is this region here. And this implies that the probability of z less than 30 minus mu over 4 equals 0.7. In other words, the region below the z value. Now, using our calculator, we can input mean equals 0, standard deviation equals 1, and probability equal to 0.7. In order to find the value of z for the probability of z less than this little z equals 0.7. So plugging all these in gives us that z equals 0.5244. Now we can equate 0.5244 to 30 minus mu divided by 4. And rearranging in order to find the value of mu gives us that mu equals 27.9. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's take a look at part A first. A machine makes marbles with diameter x millimeters, modelled such that x is distributed normally with mean 45 and variance sigma squared. Given that the probability of x less than 37 equals 0.0548, find the value of sigma. So let's solve this. We have that the probability that x is less than 37 equals 0.0548. So we have this expression. Notice that we've subtracted the mean and divided by the standard deviation on both sides. And so we have that the probability of z less than 37 minus 45 over sigma equals 0.0548. And now we can use our calculator. This time we're going to use the inverse normal distribution function and input mean equal to 0, because of course we're dealing with the z variable now, standard deviation equals 1, and probability equals 0.0548. To give us that if we have probability z less than z equals 0.0548, then this little z equals minus 1.6. So now we can equate this minus 1.6 to the value 37 minus 45 divided by sigma. And rearranging this gives us that sigma equals 5. Now let's take a look at part B. For the same distribution, we're required to find the 80th percentile of the diameters. So let's solve this. We know that the mean is 45, and from part A we know that the standard deviation is 5. Let A be the 80th percentile. Then we have the probability that x is less than A equals 0.8. Using the inverse normal distribution function on your calculator and inputting mean equal to 45, standard deviation equal to 5, and probability equal to 0.8, we will obtain that A equals 49.2. Therefore, the 80th percentile is 49.2 millimeters. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So in this example, the normal distribution x is distributed normally with mean mu and variance sigma squared. Given that the probability of x is less than 28.9 equals 0.975 and probability that x is greater than 23.3 equals 0.8, find the value of mu and sigma. So let's solve this. The probability that z is less than z1 equals 0.975 can be shown here. The reason why we've introduced the standard normal variable z is so that we can link it back to x. Now we do know something about z, essentially that the mean is 0 and the variance is 1 for this variable. And we of course want to link this 0.975 probability back to the probability that x is less than 28.9 equals 0.975. So this should then hopefully tell us something about the mean of x and the standard deviation of x. So let's continue with this. We can find the corresponding value of z1 by using the inverse normal distribution function on our calculator. For this we will need to remember that z is distributed normally with mean 0 and variance 1. So we will need to input in our calculator the mean 0, the standard deviation 1, and the probability 0.975. In order to obtain this value, z1. And when we input this using the inverse normal distribution function on our calculator, we obtain z1 equals 1.96. Now consider the probability that z is greater than z2 equals 0.8. This is represented by this region here. We're going to use the standard normal distribution as this will help us to find the mean and the standard deviation for x. Now, probability z is greater than z2 equals 0.8 implies that the probability that z is less than z2 equals 1 minus 8. So we have that the probability of z less than z2 equals 0.2. Now I can use our calculator and the inverse normal distribution function on it to find the value of z2. Remember that z is distributed normally with mean 0 and variance 1. Therefore the mean is 0 and the standard deviation is 1. And also we have that p equals 0.2. So using the inverse normal distribution function on our calculator gives us that z2 equals minus 0.84. So now we have these two values, minus 0.84 corresponding to p equals 0.2 and 1.96 corresponding to p equals 0.025, as shown here. Now we can use these values in order to help us find the mean and standard deviation for x. Notice that 1.96 equals 28.9 minus the mean divided by sigma. And similarly, minus 0.84 equals 23.3 minus mu divided by sigma. Therefore, we now have the following simultaneous equations. And so we can solve for mu and sigma. If we subtract the equation 2 from equation 1, we obtain 2.8 sigma equals 5.6. And this gives us that sigma equals 2. And substituting this back into equation 2, allows us to find mu, which is equal to 24.98. This brings us to the end of this session. If you have understood its contents, you should be able to find unknown means as well as standard deviations for a normal distribution. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.